Should be any second.
Yeah, we are ready. Hey, everybody, it's the man with the red beret and my friends around the screen on our weekly vlog podcast known as the SBAU Astro Hour, heard live every Monday morning, 11 to noon, for the South Coast Longtime Astrophysics and Telescope Club we call the Santa Barbara Astronomical Unit. I'm Ron Heron, Vice President until Friday. We'll see if we get reelected along with the President and others I'll introduce you to. This is episode number 93, if you can believe that, for the magical end of the November week, 28th through the 4th of December, keeping in mind that this Friday night we all meet again live inside Farron Hall. Let me get that off my screen. Dell is putting one of those little boxes on. Today, now I've lost everybody with a blue screen from Avast Security. Thank you. Okay, what are we going to talk about this week? The viewable planets in our night sky, Mercury, Venus, the big gas giants, they're all out there. From our November science speaker a couple of weeks ago, we visit again Sagittarius A, which is a star essentially, but it's actually one you can't see, called our big supermassive black hole in the center of the galaxy. We're going to talk about that again this hour. Speaking of black holes, you know, we got one being orbited by a sun-sized star like our sun, about 1,600 light years away. It's the nearest black hole to us. And the latest on the Artemis mission. It's on its way back from the moon. Wait till you hear the route it took. So we're getting ready for this Friday night, and let me introduce you to the gang. Jerry Wilson is doing webmaster duty, our president, until Friday night. I'm sure it's I'm sure if neither of us win, we'll just deny it, okay? Married to Pat Forgy and has been president for 5 years. I think I came in 4 years ago. Chuck McPartland is outreach coordinator and does a good job. As far as I know, that's pretty much all he wants to do, and he does very well. You've been in office, haven't you, before?
Years ago.
His wife, Pat, is the merchandise manager, and she's awesome. We have Bruce Murdoch gone, but are you there, Bruce? Can we hear you?
I'm doing my Android decided to do a system update.
Oh,
so I can hear you.
That's fine. You're very ugly anyway, so we don't want to see you.
Oh, that was yesterday. I'm uglier today.
Bruce is a longtime member, president of the Santa Barbara Theater Organ Society, and married to Bonnie. And Tom Whittemore is with us, looking down from Westmont College. He was there in the lab teaching science for many years, editor of the Santa Barbara Astronomical Unit newsletter, which is due any day now, isn't it?
It's out.
Oh, it's coming. And I guess we don't have a book speaker. It's our president and vice president, which would be Jerry. And Jerry's going to talk about your new observatory in the backyard.
Yeah.
Me, I'm just going to throw.
You might also point out that Chuck just received an honor from the Independent.
I'll let him tell us. Oh, there's the cat to tell us. Thank you. A black cat on the screen. What does that tell you? Especially
familiar.
Yeah, people have told me that you were honored. Who wrote the story or who contacted you?
Oh, it's the Independent. Every year they do a local heroes issue, and they pick 10 people that have been nominated. And yeah, so I'm in the Indy.
Well,
I keep forgetting my cape, my hero cape, but oh well.
I won their best announcer duties many years ago, but they didn't know who I was. So we do see sillies. Ladies and gentlemen, our president forwards to us silly science cartoons. Most of them are about space and things going on out in the cosmos. This one is the man and woman in their living room. I think that's a woman. Yeah, you gave the Milky Way a bad review, honey. He says, it made me feel insignificant. I think he speaks for all of us, doesn't he? And an old Peanuts classic that I'm going to have to fascinating, completely fascinating, Sally. It's Charlie Brown out with Sally looking at the night sky. See that group of stars way up there? That's called the Big Dipper. Shape of the Big Dipper, he says, changes over the years because of an unequal movement among its stars. It's cut off on my screen at some of these words. In another 100,000 years, he says, it'll be totally gone. And she goes, after a brief pause, what? And I think Sally speaks for us. Yes, we got to talk about that. Now, what is this? Turkey visits fortune teller? No, astrophotographer. Oh, it's whatever it was, it got away, right? And it's marking the inside of the shell till the day
it was bored before it got out.
Okay, got it. I think I figured that out. I don't have my notes on that one though. Oh, and this turkey visits a fortune teller who simply clams up, and the turkey says, oh, why the silence? What's in it for me? Yep, unless you go to the president's place. When your parents return from space, here's what happens when they come off the rocket ship. Hi, kids, we're back. And they're on walkers and wheelchairs and canes.
In physics books, this is known as the twin paradox, if people want to look it up on the internet or something.
A little bit of Interstellar, the movie.
Yeah.
This one I don't recall.
This is the one you needed it decoded.
Oh, did everybody else get it decoded? Aha.
No, apparently I screwed it up for everybody.
And what's he doing? God is touching a meteor? The trail of a meteor. God, who drank decaf by mistake this morning, slightly alters the trajectory of comet X348 and puts it on a collision course with planet Earth. Well, so much for the all-caring God.
I need the full caffeine every morning.
Yeah. Now you're gonna have to. Can you enlarge this?
This one might be too hard, and the printing might go away here. Yeah, it's not readable.
Well,
my favorite cartoons are these non sequitur things.
That's true, but basically, they're looking for something on other planets, and they've come to an exoplanet. Sure enough, there it is.
Yeah. They come in the spaceship, they send out the landing craft, they re-enter, and then from that they get on a rover and they go over the hill, and there's the Starbucks they were looking for.
Starbucks is everywhere. It's even in my supermarket. I kid you not.
I think the cartoonist there, Wiley, I think he lives in Santa Barbara.
He might. I think he's some of the best cartoons under that non sequitur label.
That's what it's called. That's non sequitur. Good stuff. This one I don't recall. Heroes are remembered, legends never die. He's saying that on the outside of a castle, looking over, up at the sky. Aha.
There's asterism is rising. This is, as it says down on the lower right, this is the happy 100th anniversary for Sparky, which is the nickname of Schultz, Charles Schultz.
Sparky?
That's what his nickname was.
That's why a couple of days ago on his birthday on the 28th, that's a lot of the cartoons all had references to
Well, I got news for you, gentlemen. Today is the 28th.
Dang.
Now
it was earlier then, 26 maybe.
Okay. Now, this was just a cool statement. It wasn't necessarily
that's not Vincent Van Gogh, and that's not Starry, Starry Night.
Yeah, he's got Starry, Starry Night down there. This is what he's looking at. This is how he sees it.
Yep.
Very interpretive.
Not exactly.
The picture of his face looks almost like it's a photograph.
It kind of does, doesn't it? And
it's very detailed.
Yeah.
Doesn't look like Denmark or Brussels, Belgium, wherever he lived. Looks more
he was
like
in Provence in the south of France.
Oh, really? They have mountains like that around here?
Yeah.
No.
Not near Arles.
Not right there.
Not right there.
In the distance. Those are the Alps or
the Swiss Alps are just a ways over.
Gotcha. All right. Empty shelves and the woman inside, I guess it's a scientific laboratory. So this is where we keep all the evidence of string theory. You can see a big pile of strings in there. Here's a couple of construction workers, didn't get it right. Looking at the plans, I'm starting to think our math might be off. And
gotta watch those sneaky little decimal points.
That's right. That's a whole stadium between them. This scene. Well, you keep us smiling, Jerry, over the weeks that we've done this, and there's no end in sight. And how you feel about meeting back? Any predictions on Friday night? Are we going to have a huge crowd or hardly anybody show up?
I have no idea.
I think it'll be in the middle somewhere.
Okay.
Well, it'll be like we used to have, 35, 40 people.
I think fewer than that, actually. But
remember when we served food? Remember the food at the end we used to have? And
yeah, that's a no-no.
Yeah, we were violating health codes.
Well, now, one other quick thing. I don't have anybody running for anything. There was somebody mentioned at our last board meeting a couple weeks ago outside of Palmer Observatory, but you said no, he wasn't even a member of the club, whoever it was. So you and I don't know, we may be a shoe-in. We'll just get it over in no time. Show of hands. And we're also going to be hybrid, or is that the word? We're also going to be transmitting.
Yeah,
So if
there
you
will
can't
be
make it,
an in-person component and a Zoom component.
okay, love that, Chrissy. Now, did you happen to know if our regular webmaster, Mr. Totten, is back doing planetarium duty on Monday mornings? That's why he's not on screen with us.
I know he's been doing planetarium shows. I don't know if he is right now.
How many people show up for the planetarium shows, I wonder?
Oh, that goes all over the place. You mean the normal ones at the museum?
Yeah, because that's a fairly small auditorium.
Yeah, it holds like 45 people, I think, max, somewhere in that neighborhood. And you get anywhere, yesterday it was 12 for one show and 11 for another and 24 for another one. So.
And we're going to get one Friday night. I've forgotten the time on it. Is it 7 that we?
That's 7 for a planetarium show. Yeah, it's
We'll
7:30
get there
for the
about
meeting.
6:30, 6:45, get to the museum, get parked.
And it might be drippy. It might be raining.
Oh, that's right. Your president told me that earlier when we logged
The
on.
clear sky chart is then not very, doesn't look very good for the rest of the week.
Yeah.
Guys, start a chart. Well, let's talk about the planets that are up there anyway. It started at the beginning of Jerry's talking points. Mercury and Venus going to rise in the southwest shortly after sunset. They'll be together, about 11 degrees apart? No, 1 degree high. Well, that's right.
Yeah, I mean, you've got to come out and look over the bluff to the ocean to see that.
Yeah.
Okay, and then Venus is at magnitude -3.9, Mercury magnitude, let's see, -0.7. The lower the number, the brighter it is, right?
Yep.
So what's it?
Venus super bright. Somebody just recently on spaceweather.com got an image of a full Venus.
Really?
Which is,
Oh, when it was backlit?
yeah, no, full Venus. So
Oh, the other side, yeah, full
yeah,
Venus.
when it's on the other side of the sun. So it was very close to the sun in the sky, of course.
Yeah,
So he had to be really careful, but he got an image of it. You don't normally see it fully illuminated because it's in line with the sun and on the other side.
Well, would it be safe to say or fair to say that it is about as bright as a crescent on this side as it is fully lit up on the other side of the sun?
No, it's much brighter when it's a thin crescent.
Is it really?
Yeah,
because it's much
distance.
closer.
Yeah.
Okay, gotcha. And there's an opposition in there somewhere, but the Mercury, Venus, and then we'll go out to the gas giants. Are we looking inward or outward on this map, Jerry?
This is, we're always looking up in the night sky.
Oh, that's true. You're right.
Oh, over here on the above Orion, and this is at let me just get that over there. This is at 9 p.m. Pacific Standard Time tomorrow night. So
Okay.
it's essentially the same tonight. Over here is Mars in Taurus.
We'll be talking about Mars later on in the show, we hope.
Yeah, well, Mars is the big headliner this week. Jupiter, Neptune.
And Uranus off on the left.
Oh yeah, that's good. I was looking for that. Thanks. And Uranus. So pretty much everything's in here except Saturn. These can all be seen at once.
Yeah, my 9 Saturn is close to setting.
Yeah.
About the first quarter moon. So is that what's brightening the sky on this picture?
Yeah, this is the moon near Saturn. They're both low in the west. This is at 8:30 a.m. tonight. So it's shortly, it's early evening. Go ahead. Someone's trying to talk. Go ahead.
I was just going to ask about quarter versus half. What we're seeing is a half of a moon, but it's called quarter because it's a quarter of the moon's surface, right?
That's right.
That's a quarter.
It's a quarter of the way through its phases too.
Right.
But we call a full moon just this side, all half of the moon lit up, the part that's facing us, right? That's still a full moon.
Yeah, well, half of the moon is always illuminated, right?
Yeah. It's always a full moon from somewhere.
You have to be on the outside of his orbit.
Okay, well, it's just strange. It goes from this, which is the taco shell half, but it's a quarter and fills up the other side and becomes a whole full. I mean, you should buy your milk that way.
Yeah.
When I was young, we used to have a charity fundraiser called the March of Dimes.
Yep.
And they give the kids little cards at school, and they had these slots that you could stick a dime in, and then
Right.
turn the card in at the end of the week. And this always reminded me of the dime that stuck out, because it fits halfway in the slot.
But just for the record books, this is a quarter moon.
This is a quarter moon, and it happens on November 30. Now, the other thing that happens on November 30 is that Mars reaches opposition same night. So,
Meaning the closest to us.
yeah, meaning the closest to us for this combination of orbits. The Mars is going to be as big as it's going to get, which is just under 18 seconds of an arc. And starting tomorrow, or starting the 31st or the 1st, it will begin to shrink in size as we pull away. We're going faster, as we pull off into the head.
Well, as long
Carlos
as
and I was set up at the old Camino Real that's north of Refugio. And I tried to get an image of Mars, but it was just wiggly.
Yeah.
I don't know how these people get such clear images from Earth.
Well, a lot of them use video and do what's called lucky imaging. They just have so many frames that they can pull out the ones that are steady.
Actually, Deep Sky Stacker will do that for you.
Yes. Number of programs.
there's a system that'll do that. Isn't there something that clarifies the wiggles of the atmosphere? And
Oh, that's adaptive optics. Yeah.
oh, okay.
That probably wouldn't work if you had a really, really turbulent night, though.
Well, I wonder if before we go to the magma part, I'd like to kind of stick with Mars for a while, gentlemen, if you don't mind.
Okay.
Anybody ever attempted to do what was first seen using an old telescope to see if they could take out canals, look at lines?
A lot of people.
A lot of people have tried that, and it's
Yeah.
just
Optically, some people claim they can see them, and some people say they can't see them.
I think I saw an analysis in Sky and Telescope once where they said it's because they were using eyepieces that were really small exit pupils. And so what people were in effect seeing was defects in their own eyes, you know, things like the blood vessels and on the retina and defects in their cornea. And those are often linear looking features. And so that's why they were seeing that.
well, there does happen to be a big long canyon that makes our Grand Canyon look like a gully on Mission Creek.
I don't think that thing ever showed up or ever was interpreted as a canal. I don't think.
It's a low contrast feature.
Yes. Now the human eye also has a tendency to see things that aren't there. And so
the human eye and the brain want to make faces out of anything.
Right.
Really, yeah.
Or lines or other geometric features.
Right.
And so observers have fallen victim to that illusion.
Yeah, pareidolia.
Okay, yeah.
So this picture we're looking at now, Jerry, could have been taken by Hubble or Webb? Or
No, this is taken by an amateur, and I think this was taken in 2017.
Probably Damian Peach. He's really known for planetary.
well, it would look much better from one of those space
Yeah,
telescopes.
this was taken in December 2007.
Yeah.
And does not, there's no, I don't have a citation for who took it, but it looks like an amateur telescope.
There are Hubble images of Mars. I don't think James Webb has looked at it yet, or at least they haven't released any images.
Yeah.
Well, can we talk magma? Is it possible that it has, it doesn't have big tectonic plates, but it does have Mars quakes, apparently? I have to go to the end of your talking points on this part, Jerry. Tell us what you know.
It has sort of one big, huge plate is the problem.
Is that what it is?
And it's cooling and shrinking. So there's all kinds of stress.
But the InSight lander detected 1,300 Mars quakes over the past couple of years, or let's see, it touched down in 2018. And the closest one was 700 miles away. You'd think they'd that many quakes, it'd be everywhere, even around it somewhere.
Well, they tend to bunch up for someplace in a place called, what is it, Cerberus Fosse.
Well, eventually they're going to have a map of fault lines, aren't they? Or would that not be something you'd see on Mars's surface?
I don't know if they gathered enough data to do a whole lot of fault line stuff, but they could at least pinpoint where they tend to occur and see if any of the features look linear.
What they're getting,
It also
Go ahead.
depends whether the slip strike fault or they're an overthrust fault. Like there's a lot of faults on the East Coast, or especially around New Madrid and whatnot like that, they're overthrust. So they erode away in time. But the big earthquake they had there, and I forgot when exactly it was, 1860s, that magnitude 9, people were thrown up into the air like 30 feet. And then they came back down as the earth came back up, and that really ended their life.
Whoa. Well, I've never heard that.
You know, you can't find that, you know, from space taking pictures. You don't see that fault anymore. You don't see any of the evidence of it because it's a overthrust fault rather than a slip slide fault like the San Andreas is.
Yeah, but this InSight mission is actually on the ground there, so they wouldn't be getting imagery. They'd be looking at, you know, 3D
and they're measuring the wave.
triangulation.
Well, I understand that, but one of our participants here was talking about getting an image of the fault lines on Mars.
Yeah, I mentioned that, but they require tectonic plates, don't they? The ring of fire around.
They don't require it. They don't require it, but that really amplifies the number of earthquakes you get.
Well, I think the point of this magma section is that there are two types of earthquakes that have been recorded on Mars: low frequency and high frequency oscillations. And the low frequency are very much like earthquakes. The high frequency is not like an earthquake. They're not quite sure what it is. And but they're putting together a model that seems to indicate that it's due to magma moving below the surface, which indicates that Mars may have some latent volcanic activity.
What about
this is a picture from that. This is a picture from that region. What is it? Cerberus Fosse? Yeah, Cerberus. And it shows a young, fresh crack in the surface. But it does not imply that this is an earthquake fault. It may be that they're still trying to track down the source of these things.
And one of the sources they heard was an impact,
Yeah.
a double impact, and they managed to trace it and get a picture of it from an orbiter.
You mean an asteroid hit and caused a Mars quake?
Yep.
An asteroid and its moon.
Yeah.
Suppose that happens a lot on Mars. It doesn't have a thick enough atmosphere to burn them up, right?
Right.
They
I'm
would.
guessing it happens there more than here.
Yeah.
Both from the neighborhood and its shielding.
In our atmosphere, an incoming piece of sand ignites and combines with oxygen and becomes a flaming meteor, right?
Well, Ron, the meteor that you see, the meteor is the glow effect that you see, and it's actually often not. It's not combustion like you're implying there. It's that the object that enters, the meteoroid, is traveling so fast that it ram heats the air in front of it and heats up the air, and the air fluoresces. So some of that heat can get transferred back to the meteoroid if it lasts long enough and cause it to slough off its outer layers. But in general, it's more than just the heating of the atmosphere.
So falling stars are on all the planets. You'd be, if you somehow were on a gas giant, you'd still see it flare in, and that must be a light show every night on those planets.
If you've got an atmosphere.
We like to call it aerobraking.
Yeah.
Well, where did this picture come from? One of the orbiters?
Yes, this is a picture from
Mars Reconnaissance Orbiter?
Thought maybe that was the canyon I was talking about earlier, but that sucker's huge and wide.
Yeah.
So this was taken in 2018 by the Mars Express orbiter.
Okay. Do they know how deep or how much magma is down there?
I don't think so. I haven't seen any numbers on it.
So it's
There have been a
Yeah,
number
but
of
they-
proposals made for why there are Mars quakes, and one of them was that Mars is still cooling and contracting, is shrinking.
Yeah.
But they
And
say
it has a
that
unitary crust.
they're what?
And it
Oh,
has
yeah.
a unitary, very thick crust, so the shrinking causes stresses. I think they do have a model of how much of the interior is crust and how much is mantle, and it's like 1,300 kilometers for the mantle, I think, but I don't think they have an idea yet of molten core.
Yeah, we reported on those seismic results, I think, about a year ago.
Whittemore, you got anything to add to any of this?
No, just an observer. Thank you.
I bought a record back when I was a teenager, probably around 1950, and called Out of This World. And there was a guy named Morgan, M.G. Morgan, that was interested in earthquakes. I think he was with Cal Poly. And anyway, he invented a tape recording seismometer and recorded at 0.02 of an inch per second. And then they took those tapes and they played them back on a normal tape recorder at either 3 3/4 or 7.5 inches per second. So it sped them up a lot. I remember on the back of the record, it says it's equivalent to playing the earthquakes back on a 33 1/3 RPM record at 12,000 RPM. And well, no, but you get a real good, you can hear the reverberations in the earth, and if it's a nearby earthquake, it goes crack and rumble, rumble, rumble. If it's on the other side of the earth, it's kind of just like lightning a long ways away. I'm trying to find, I put that up on one of my websites, and I'm like, right now I was trying to find it, but
Yeah, I've heard that recording. It's very, very interesting.
on the other side of the record is ionospheric effects, whistlers. And I also listened to them when I was at that age. I built a big loop antenna, and
You know where it made it on the top 10, Bruce?
no, didn't make it on the top 25 or 100
I
either.
don't think Casey Kasem ever played it.
Well, I once was given the earthquake room in one of those Halloween haunted houses. And so I just loaded the first 40 seconds of the soundtrack album for Earthquake, the movie, which was a 30 to 40 cycle sound, a rumble that was recorded. And I just played it over and over again, super amplified on disco speakers. And man, it made that room shake.
Yeah.
20-inch woofers.
You got to find the room.
The lowest recorded note was in Saint-Saëns' Third Symphony, I think, in there. It's called the Organ Symphony. And he goes down the scales, and there's one where he holds a note that's about 5 hertz or something.
Well, it's probably a 32-foot pipe, so it'd speak at 16 hertz.
You feel it in your lungs as at least half of what you hear.
5 hertz would be 5,000 cycles a second.
No, 5%.
5 hertz is 5 cycles per second.
Oh, kilohertz is 1,000. You're right.
Yeah.
Wow.
Now, when I was in school, the students upstairs were having a loud party one night, late into the night. And so I turned my stereo way up and I played that section of it. And you couldn't actually hear anything, but all the music stopped upstairs and I could hear voices saying, "Wait, what's that?" So I was rocking the whole building.
Well,
The real avant-garde hi-fi people now have actually motor-driven woofers, because the sound pressure level coming out of a loudspeaker is proportional to the acceleration of the cone, which means that goes as the inverse square of the frequency. So that's why, big woofers have to have very long voice coils. So they're, no matter what part of the voice coil is in the magnetic field, it still works. But what they're doing now is they actually have servo-driven motors modulating big panels to make that deep bass.
Well, don't they communicate with submarines with the extreme lower end of the electromagnetic spectrum?
Yeah, it's a 12 kilohertz. That's Big Jim up in, I think it's Washington or Oregon, where they've strung the antenna between 2 mountain peaks. So, it's the, again, radio waves don't propagate well in water. They, in fact, they get absorbed. But as you go lower frequency, you get more and more penetration into the water. It's called evanescent waves. Anyway, So with 12 kilohertz carrier, they can talk to submerged submarines. It doesn't really talk. They're sending code, BAU code or something like that, so that they can communicate with them when they're submerged.
12 kilowatts, or kilohertz, we should be able to hear, I would think.
Well, it's electromagnetic. It's not acoustic.
Yeah.
Oh, I see. Gotcha.
I mean, if you have gold fillings above silver fillings and you close your mouth just right, that makes a diode. And
you can feel the pulses of pain at that frequency.
Right.
All right.
Just got a text from Tim. He says that we also have Jim Williams and Chuck Watson on board, and to watch the chat if possible. But if not, he'll text it to me if they have anything to contribute.
Okay.
That would be Tim Crawford, our telescope guy, wife Karen. Okay, we're looking at NASA's Artemis coming back from the moon, Artemis 1 with the Orion.
There's the moon back in the distance.
So it's going there.
And that's the far side of the moon. So that's Mare Moscoviensis there that the cursor was on.
Good memory. I was trying to think if it was Tsiolkovsky or not.
Well, I can't wait for you to post those orbits, because it's strange what they're doing with this suckers. Not just going around like Apollo did.
Yeah.
Here's the launch. Okay.
It was the launch on the SLS, the Space Launch System, the largest rocket ever so far that works. I think there was one in the Soviet Union back in the 70s that blew up.
Can you say
N1.
basically
The N1 rocket?
Yeah.
What does SLS mean? Those two Roman candles on the side?
That's for Space Launch System.
I know that.
These are the same boosters that were on the shuttle.
And so the shuttle used Space Launch System, right?
No.
No.
That's not what that means?
No.
No, it's its own launch system. It's not riding on a rocket. Actually, it is to get up there. That's right. Well, that's called SLS. So you go down to that Science and Space Museum, which we've been to, twice now?
Yeah.
And when you go into the big room that has an actual lander, a space shuttle there, all around the edge are pictures of the various SLS launches. I think there's over 120 of them.
All of the shuttle launches, but not
SLS.
shuttle
launches. Yeah, this is the first SLS launch.
Yeah.
It uses the same boosters that the shuttle launch did.
And I think it uses the same main engines in a cluster at the bottom. And you know how it had the big orange tank on the shuttle? This is like a huger version of that for this rocket.
Right. And it's got a lot of reuse. That's NASA's favorite thing, is to have heavy reuse of things to lower risk. So you want it, NASA rules to us when we made parts or instruments for them, they wanted less than 20% new technology on board.
Huh. My understanding was those two side rockets were full of aluminized or powdered aluminum, a solid booster, right?
Yes.
They're solid, yes. This one is hydrogen and oxygen.
Oh, but it's hydrogen, liquid hydrogen. And
in the center.
Is the oxygen liquified too?
Yes.
Wow. That saves space, I guess. Makes them under a lot of pressure. Okay.
Yep.
Well, that's SLS.
Mm-hmm.
Finally got up.
And up above is the Artemis and the Orion capsule. The mission is called Artemis. The thing that's going around the moon is called the Orion capsule.
Right. Do they have dummies in there, you suppose? So
they have a mannequin, and they have Snoopy, and they have Shaun the Sheep.
Yeah, that's right. I forgot about that.
Tom Whittemore, your picture was lit up. Tom, were you going to say something?
Mm-mm.
Okay. Wait for the bread to bake.
Okay. This is a picture of some random part of the moon as they went over at about 130 kilometers above the moon.
About 80 miles.
About as close as they get to the moon on this trip. 130 kilometers. Taken on 16 November. Launched on 16 November.
Might be the far side because it's a lot more
Could be anything.
Rugged. I mean, the side we see has got big C's on it.
Yeah.
Yeah. Well, you can get, this probably is the backside, but you can get this kind of terrain many places on the moon.
The
Well,
highland regions.
Right.
any of these craters named yet?
Oh, sure.
You think so?
I'm sure they are, but I don't have access to that right here.
Here you go.
Huh. Okay, but the landing spot they're planning for is the South Pole, isn't it?
Not on this mission. That will be Artemis 2 and 3.
Yeah, that's what I meant. There's only 3
Yeah,
flights.
okay. So here's the plan for what they're doing.
The, earthquakes out of this world. Cook records, road recordings.
The yellow line is the trip out, and the blue line is the trip back.
It's
Yeah.
not yellow. This looks like lime green to me. My kids
Yeah.
called it llama vomit green, but yeah. Here's the SLS system symbolized there as an icon, and it's taking off from Florida. You can see the map of the US. It takes off this way, goes around the backside, and it loses the first stage. So you see the second stage and the Orion here. Then it loses the second stage, and this is just the Orion capsule with its solar sails or solar panels. And it heads out for the moon, and it gets flung around the moon, comes around here, and then it inserts itself into an orbit, a retrograde orbit around the moon. So now it's the Orion capsule with its solar panels going more than once around the moon. And then it fires retro rockets, and it puts itself in a departure orbit. So that sends it down to the moon for a close contact, and then it flings it by the moon past the Earth, comes in here, and the Orion capsule will separate from its support module and go around the Earth and come in and land here in the Pacific Ocean. And you can see it just west of Mexico here.
Supposed to be close to San Diego.
I don't think it's that close. This looks like it's about the width of Mexico out there. It's way out there. Might be like halfway to Hawaii.
Okay,
So
well,
but
fantastic.
this map is not a detailed map to identify the landing zone.
That support capsule you were talking about, that stage behind the Orion, will
Yeah.
hold a landing craft for the moon next time, right?
No.
On the third flight.
No.
How's it going to land?
Well, when it goes out here on Artemis 2 or 3, it's going to do something like this, and then it's going to get into a parking orbit here around the moon, and it's going to dock with a space station around the moon called the Gateway. And the Gateway will already have a lander refueled or fueled on there, and then it will take the lander down to the moon's surface. And then later the lander will come back up, dock with the Gateway, and then they'll get back in the Orion capsule and head back to Earth. So this parking orbit, they're just simulating the parking orbit, but not the docking, just going around the moon there.
Wow. So that Gateway is like a space station.
It is a space station.
Okay.
We got a question from Chuck Watson was, why are the pictures of the moon from Orion or from the Artemis mission such high contrast? And I imagine that's because you're real close.
I think it's just that no one has sat down and done processing in it, because I can see a lot of errors in it, little streaks and lines and hot pixels and stuff. So I think it's a as is single frame, which can sometimes look pretty ratty.
Well, isn't digital photography relatively new, like last 30 years? And during Apollo's time, they had regular old silver-based photography?
Yes, they had film then.
Okay, so maybe the technology has gotten better. The pictures look brighter and neater.
They have gotten better, but also the image processing techniques have gotten a lot better. But they take a lot of time, and they're manpower intensive in many cases. You can also do them automatically with software, but they tend not to come out as good, in my opinion. Back in the 60s, when they first were mapping the moon in detail, they put orbiters around the moon, and they took long strip photos of the moon. And then they put these strip photos side by side and it showed pictures of the whole moon, but it was covered by this grid of lines. And my favorite cartoon one time in the paper, they showed an astronaut on Apollo that had landed on the moon, and he was looking at the moon he just landed on, and it actually had slip faults along those lines. So it was all broken up in chunks, and he goes, "Well, I'll be damned."
Well, find that cartoon, Jerry. That's your assignment, and forward it to us, please, for next time.
Okay.
It's great. So that Gateway station is going to stay out there from now on. That's going to be our orbiting laboratory.
It's not there yet.
It's not there yet. They're still working on it. And I believe I read an article that the Chinese are open to participating in the Gateway image, or the Gateway satellite production, and bear some of the expense of it. The Chinese have run their own space program quite successfully because the U.S. doesn't want to work with them in the past, but I think that may be loosening up a little bit now.
And they've already done something that's sort of similar in that when they landed one of the Chang'e orbiters on the far side of the moon, they had to have an orbiter to relay communications with it. So they've already done something on a small scale that's very similar.
Mhm.
Well, we don't need a Cold War in space.
We don't need a Cold War anywhere.
Well, yeah, the more cooperation we do, the better off we'll all be.
Our days of riding Russian rockets is over.
Well,
Yeah, but Russia still has a stake and astronauts in the ISS.
Oh, do they really?
Yeah. Although the ISS has been evaluated for its mechanical, what do they call it, integrity. And they decided that it's coming toward the end of its life, being in space and continually pressurized from metal fatigue and all sorts of things. So the estimated lifetime end from the US side is 2030. But Russia says that they've seen more, they've had a leak in their module up there. And they say that it's more like 2024 or 2025. And they plan on pulling their astronauts out of there before their component is at failure mode. But I don't know how much of that is political and how much of that is actual mechanical engineering.
Wow.
I thought the Russians were going to deorbit their portion of the space, the orbiter.
you can't do that.
Well, either that or they're going to shut it down, block it
Yeah,
off.
well, that's it. They're going to shut down. But
They're
their computers run some of the systems in there, like the life support systems, I think. So it's
You're screwed.
Also, in the last week or so, we had a big solar flare that came by us, and it has damaged the orientation computer on the ISS that keep the ISS stable. So it's got they're having difficulty working around that. It's still an unsolved problem.
Jeez. So eventually they're going to let the sucker plunge into the ocean?
I think they're going to plunge it in on purpose.
Well, that's what I meant. Yeah, right. They'd have to do it that way. It's one big piece of junk in space. You don't want to get hit by that.
No.
But there's two other space stations. One was the Mir. That's shut down, right? That was the original Russian.
that's already at the bottom of the ocean.
Oh, that's done. Okay. And then when we saw the Chinese one going over, it was unoccupied, I believe. Chuck?
Yeah, Tiangong, yeah.
It's occupied now. They added the last module to it. It's done. And I saw pictures of the inside of the Chinese space station, and
Really?
it looks like a set from Star Trek.
Star Trek.
Very clean walls and nice little cornices and stuff. And then they showed a comparison of a hallway in the ISS, and it's just loaded with instrumentation and wires dangling down and loops, and it looks like my office.
Yeah. Well, the inside of the Orion looks kind of technically up to date too. Something like a Kubrick film, 2001, Space Odyssey.
Yeah, and I guess the someone's planning on building a space hotel in the next 3 to 5 years up there.
Yeah, we heard that.
Yeah.
With inflatable modules.
Yeah,
So if we're going to share the gateway with Chinese, if they get on board, there's no reason we can't be in their space station around the Earth either, right?
I don't know. That's not for me to decide. That's above my pay grade.
But is
I
that what
just,
it might involve if China wants to get on board and we welcome them on board, there'll be Chinese astronauts going to the moon with our guys?
I guess that could be a possibility.
They
Wow.
call them taikonauts.
Well, it might keep them from invading Taiwan. Interesting. Are the future flights of Artemis going to be exactly the same route?
No.
Different.
Yeah.
Tom, you want to get that? Share it with us.
It's probably spam.
But they're going to land on the third one, aren't they, Mr. President? The third.
Taikonauts or Tycho? Are you?
Taiko.
Oh, thank you. Okay, somehow I got frozen up, but now I think I'm back. Can you hear me?
Yeah.
Yes.
Okay. Okay.
Are we landing on Artemis 3?
Yes, with people.
Okay. So that means the Gateway space station has to be in orbit.
Yeah.
And how many live bodies? 4?
Boy, I've forgotten that. I think, yeah, it could be.
One of them's going to be a woman. And they're going to one of 13 places on the bottom of the moon, right on the South Pole.
That was the plan. Can you see my share screen now?
Mhm.
Okay. Moving on.
Okay, we're going to look at that. Is that the center of our galaxy or that other black hole 1,600 light years away?
No, at the time we took pictures of the black hole at the center of M87. We also took pictures of Sagittarius A at the center of our galaxy. And this is that thing. Let me just close this a second and see if I can get a video of it.
Okay.
Let's see. If anyone knows any good jokes now, would be the.
Well, I can tell you what you sent us. Animated computer simulation was used by the new band of researchers to come up with what it might look like, and past all those clouds, swirling envelope of plasma around the supermassive black hole. And believe it or not, ours is smaller than the M87 center of their galaxy. Remember that came up, what, last year or earlier this year?
Ours is much less massive than theirs. Of course, that one is bigger in M87.
Okay, so M87 is a bigger galaxy than Milky Way.
Oh, that's like a 3 billion solar mass black hole. But that one was actually easier to image because it changes. It's so far away and so big, it changes on time scales much slower than the local one. And so in the local one, you have to try to filter out what's a lasting feature of the image you see and what's just a little temporary thing that's happening.
But they both look similar in that there are lumps of bright orange around a centralized dark area.
Mhm.
Like we're seeing it face on. And if we were to see it side on, I mean, is that an accretion disk that would block out the black hole and all we'd see is a flat line of yellow brightness?
You know, that ring you see around it is the accretion disk, but it's not like we're looking down on it. It's actually, you're seeing the far side of the black hole because gravitational lensing is bringing that image around and into your view. So it's really weird stuff that's going on there.
Okay, but we can't see the stars even in radio waves that are out there, just that accretion disk sending out X-rays, gamma rays.
Yeah, all kinds of stuff. They're screaming as they go in.
Wow. What are you looking for, Mr. President?
Well, something that I've looked at several times to make sure that I was good and efficient at finding it. But, now it's coming up with all these things. Your security is looking bad or something. So.
Well, now it's called Sagittarius A.
Sagittarius A star.
Yeah, I know it's called a star. Why?
No.
No,
A star. The name has an asterisk in it, and it's pronounced A star.
Where is the asterisk? After the A,
Sagittarius A star. Yes.
they say star. They say the word star.
Yes.
No, the asterisk is a star.
Oh,
Yeah, the asterisk is a star. They say the word star for the asterisk, but it isn't a star. It's a black hole.
and it's in Sagittarius.
Yeah.
Okay.
And it's the loudest X-ray source there, so it got the or radio source there, so it got the name Sagittarius A. But the actual object that's causing it is Sagittarius A star, which is the black hole.
But it might be located right in the middle of that big angled, the Milky Way we see at night, past all the clouds and dust.
In Sagittarius, yeah, at the sort of dynamic center of the galaxy.
Okay, so Sagittarius is on our ecliptic, therefore it's part of, like, we're looking through the zodiac to see it.
Yeah, well, yeah.
It's not
Not
over.
like the zodiac is a physical thing, but yeah.
Yeah, I understand. But I mean, that's the ecliptic of the sun is what the zodiac is, isn't it? 12.
Well, the ecliptic is the apparent path of the sun through our sky. Yes.
Okay. Jerry, are you still looking?
Yeah, now I'm trying to get out of looking.
You want to,
Trapped.
you want to tie in the one that's in Ophiuchus, 1,600 light years away, a black hole?
Wait a second, I got to get reoriented here.
You may be stuck in the event horizon there, Jerry.
Yeah,
Lord. Well, this is the closest black hole to Earth.
okay,
Might be a lot of binaries out there that are
that's not what I want.
half star and half black hole that you can't see.
The first black hole was found was that way in Cygnus X1.
Where is it?
In Cygnus.
Cygnus, University of Arizona. Tim Cox.
Is it just sitting there in space, or does it orbit?
No, it's a binary system with an X-ray emission.
And back then we didn't know about black holes, so somebody said it's orbiting something, but we can't see it.
Right.
Okay, and we're back to this. What is this?
Okay. Well, it's one frame out of a movie. It shows it very rapidly spinning and throwing off these red streaks. And then this is a diagram that breaks it down of what Sagittarius is from their picture. This is equivalent to the one in M87, where it shows nodes around here.
Very
And
simple.
it shows the structure, the size. Apparently, these images give you the ability to measure the size of things. So the event horizon, which is not a real surface at all, it's just a mathematical point, is here. So we're getting absolutely nothing from here, although we are getting light from superimposed in the front of it. So it's not a completely black hole for us. This is the black hole shadow. Emission ring. This is where we're getting a lot of the thing that rotates around in the previous picture. This is the emission ring.
Emission ring.
Emission ring. You get a lot of emission from that. That's the hot spot in the ring where things colliding with itself. Emission ring diameter 63 kilometers, 63 million kilometers. So the action around there is pretty big. The black hole shadow diameter is 59. This is about 60 to 100 million kilometers across.
Jeez.
Not light years. It's not that big. So anyone know what 100 million kilometers is in light years? Probably about a tenth of or a hundredth of a light year. So this is
100 million?
Yeah, 100 million kilometers.
6 times 10 to the ninth, right?
Yeah,
Well, we use miles in this country, so it'd be more like about 70,000.
6 times 10 to the 10 for
700,000. Yeah. Okay.
So that's going to be on the order of 100th of a light year.
Yeah,
Really, it's that small. Relatively speaking, I thought it was hundreds of light years across.
Well, I think I've read somewhere that the event horizon would, if you put that black hole at where our sun is, the event horizon would be out around the orbit of Mars. So that's
Okay.
about 150 million miles for radius.
About 2% of the orbit.
But the singularity is in the middle of that, and it doesn't have a surface or a
2% of a light year. I mean, what am I saying?
When you refer to a singularity inside a black hole, you're only referring to ignorance. Nobody knows what happens inside the black hole. We don't know whether mathematically you can go to a singularity, but Einstein and several other people believe that the universe will not allow a singularity. So who knows?
In this photograph, Jerry, is the double ring representing the event horizon?
No, the event horizon is written over here, event horizon.
Oh, it's the black.
That points to this
I
region
see
here.
it now.
Now, if you were to come in here and pass through the event horizon, as you get there, of course, light can't get past the event horizon. So as your feet and your knees go into the black hole, you can't see them anymore. So, I mean, other things, horrible things would happen, but let's ignore those for a minute. And so as you, what's that?
Spaghettification.
Yeah, we'll forget that. So,
well, not necessarily on a really big black hole. I think this one's big enough that you wouldn't get spaghettified.
I don't know.
Yeah.
Not a black hole expert, but when you're in the black hole, suppose you're 2/3 of the way from the center to the edge, and you look down, all you'd see is that your body's not there, because you can only see things from up above that are up above because light comes in, but nothing can come up because the gravitational field is stronger than it takes to shut light off. The black hole surface is where the light just can't get out. It just doesn't have enough energy. But inside farther, the gravitational field is very efficient at holding the light back. So you wouldn't see anything from farther in either. It's not like you pop your head inside and you can see all this structure in there. You would stay ignorant of what was happening to you, at least visually.
I understand that time stops there too, doesn't it?
Well, yes and no. It's relative. If you were to have a spaceship that came in, and you were here on Earth and you were watching that spaceship as it came in, as it got closer and the gravitational force increased, the spaceship would speed up. But as you got into an intense gravitational field, the time for that spaceship would slow down. And so the spaceship would come in real fast, then it would appear to slow down, and it would appear to slow down, and then to reach the black hole's event horizon, it would appear to stop and never enter. So for that guy, his time clock, viewed by us, is stopped. But if you saw him, you were he, as you came in here, you'd notice that you increased in speed, and you continually increased in speed, and then you just went into the black hole. But you would go fine. But if you were looking back out, if you had a telescope in there and you were looking out, you would see that time outside of the black hole started speeding up. And in the background, you'd see galaxies. And as you approach the black hole surface, you would see these galaxies are starting to rotate. Because out here, time is going very fast for that person. Confusing, no?
Yeah.
Well, the part I don't understand is everybody goes out of their way to insist that light cannot leave, it gets sucked in and it's subject to gravity. And yet, look at all that light that gets away. How does it do that? Why does
That's all generated outside the black hole.
Yeah.
Generated by what?
Outside.
The
Friction.
stuff falling in is moving really fast, and the pieces are hitting each other, and there's friction, and so it's very hot and it's radiating like crazy.
And anything it throws out can get away from the black hole. It doesn't get flipped
Because
around.
it's not in the event horizon. Yeah. It's light.
I would imagine black holes gain a lot of weight every day.
Theoretically, even the light coming into them is adding to their mass.
Yeah.
Well, I don't know how. Light is nothing but pure energy.
No,
you
energy
know-
is mass. There
you know-
equals MC squared.
There is
Right.
a thing called Hawking radiation where particles do get out of the black hole, sort of.
That's
And it
because they
causes-
split.
It causes black holes to evaporate over very long time periods. what happens is that just outside the black hole surface, pairs of particles and antiparticles are created spontaneously out of the vacuum of space. And one of the virtual particles, and one gets sucked in immediately into the black hole. So the other virtual particle, because they were separated very quick, now becomes a real particle, and it has the energy to escape from just outside the black hole. And that takes energy out of the black hole. So eventually that will cause it to evaporate. It's called Hawking radiation.
And the smaller the black hole, the faster it evaporates.
Yes.
But the only thing in the universe that goes the speed of light is light, and it? Particles
Yep.
can never reach that speed.
That we know of.
Okay. Wow.
Within the space-time fabric.
So when we're seeing these very distant 13 billion mile away galaxies, we're only seeing light. We'll never see the particles that came out of their coronas or.
No, you'll see them too, but just not for a long time. They're traveling slower.
Well, gentlemen, what a way to end. I guess
Oh,
they'll
are we 12 o'clock yet?
be, yeah,
Yeah.
Oh, dang.
1201.
we'll see you all on Friday night, 6:30. Get there early. I'm going to have a special guest or two along with me. And who's going to do the show in the planetarium? Chuck, do you know? You're going to be our man.
I don't know if me or Chrissy. Chrissy might want to do it to showcase some of the new stuff, but one of us will.
And
Yeah.
Tom Whittemore and Bruce Murdoch, we'd love to see you there too. Take care of your wives. Thank you, Jerry. And we'll be back for number 94 on this one, the SBAU Hour.
Okay.